Hello everybody. In today's video I will show you everything that you need to know in the IB about the quadratic function, and at least for now until complex until I describe the complex roots on my channel. So a quadratic function is basically a polynomial where the highest power by x is 2. And the general formula for it is a times x to the x squared plus bx plus c equals 0. Now you've probably memorized many formulas like x1 equals minus b plus minus square root of delta over 2a. But I'm pretty sure you've never even derived the formula. You were just given it. So I think I'm gonna show you how to derive it, so you know if there might be. I mean, it's very unlikely, but I mean, if you're someone like me who likes to understand, not just memorize all of the formulas, then I think that you can find it really interesting. To be honest, I myself couldn't derive it, so I had to find a proof for that. I usually don't do that, but yeah, it was really hard. So I'm just gonna give you a proof I found in a book. So this method is called completing the square and factorization. So the first step we do is we multiply by a, our first formula. So we have a squared x squared plus abx plus ca equals 0, because when we multiply a times 0 it's still 0. And now we add well, first of all we know that a squared x squared is basically ax squared. We also can write it as plus 2ax times b over 2, because that's also true, because these 2's cancel out. And also we add b squared, we subtract b over 2 squared, and we have this ac here. Okay, so this is the part that actually interests us the most, because we can see here a perfect square. So it's basically ax plus b over 2 squared. And if you don't know what a perfect square is, it's basically the formula that a plus b squared equals a squared plus b squared plus 2ab. And that's exactly what we can see here. Ax plus b over 2 squared is basically ax squared plus 2 times ax b over 2, these of course cancel out, plus b over 2 squared. So basically all this part is this, and well, we still have minus b squared over 2, all this, plus ac equals 0. Now we can open up this b over 2 squared. So we have ax plus b over 2 squared minus b squared over 4 plus, let's say, 4ac over 4. So you can see we're getting somewhere, because now we have ax plus b over 2 squared plus minus b squared plus 4ac over 4. And hey, that bit looks quite familiar, right? Because it looks like delta, right? It looks somehow very similar to delta, right? So now what we do is basically that equals 0. We do something quite simple, because we do ax plus b over 2 squared. We put this minus here, and so we have minus here, so we have here b squared minus 4ac over 4 as equal to 0. And now what we do is ax plus b over 2 squared minus square root of b squared minus 4ac over 2 to the second power. And that's obviously true, right? Because when we put this to the second power, the square root cancels and 2 to the second is 4, so that's obviously equal. And well, you can also already see it's the delta right over here. Alright, so here is another formula that we can see, because a minus b times a plus b equals a squared minus b squared. So that's basically what we have. This is the a squared, this is the b squared, so we can actually put it in something like this. And what we get is ax plus b over 2, that's our a, minus the square root of b squared minus 4ac over 2, multiplied by ax plus b over 2 plus the square root of b squared minus 4ac over 2. And that's equal to 0. So now that we want to find the solution, well, either this has to be 0 or this has to be 0. So it's either ax plus b over 2 minus square root of b minus 4ac over 2 equals 0, or ax plus b over 2 plus the square root of b squared minus 4ac over 2 equals 0 for this, because it's either this is 0 or this is 0. So now we just have to derive x, so ax equals minus b plus square root of b squared minus 4ac over 2, and then we divide it by a, it's minus b plus square root of b squared minus 4ac over 2a. So that's our 1 root x1, and now here we have this part, and well, there's only minus, there's plus here instead of minus. I think it's obvious that ax equals minus b minus square b minus 4ac over 2, so x equals minus b squared minus 4ac over 2a. So that's x2. So x equals minus b plus minus b squared minus 4ac over 2a. So that's the general formula for x1 and x2. Okay, so that's what we have. Now this is denoted as delta, this little part, b squared minus 4ac, that is equal to delta, and for a good reason we use delta, because if delta is more than 0, then we have two solutions. If delta is equal to 0, we have one solution, and if delta is smaller than 0, we have 0 solutions. And I'd like to remind you that we're working on the on real numbers, so in reality it does have solutions, but on a complex plane. That will be a separate video. And I think it's when delta is more than 0, so the square root of delta, we have plus minus here, right? So it can either be plus or minus the square root of delta. But when we have delta equals 0, well, then it doesn't even matter if it's plus or minus. There's only plus 0 and minus 0 is still 0, so that's why we have only one solution. And when delta is smaller than 0, well then we have square root of a negative number, and that's obviously something we do not have in real numbers, so there are no solutions. The quadratic function is never equal 0 then. Alright, so now that we have that, let's try to derive the formulas for the because the quadratic function has many sort of other formulas. So we know that the basic one is ax squared plus bx plus c, but there's also a formula that says a times x minus x1 multiplied by x minus x2. So that's one of the formulas, one of the other formulas. And to actually derive it, we actually did derive it a little bit earlier, and I think it's quite visible right here. Let me just rewrite it over here. It's ax plus b over 2 minus square root of b squared plus minus 4ac over 2 multiplied by ax plus b over 2 plus the square root of b squared minus 4ac over 2, that is equal to 0. Let me check if I did it correctly. Yep, that's correct. So we know that x1 is equal to b minus b plus, let's say, b squared minus 4ac over 2, and x2 equals minus b squared minus 4ac over 2. Alright, 2a, excuse me, I think I even forgot. Nope, okay. So now that we have that, you can see that we can take a in front of both of these. So we have a times x. Here we have minus what? Minus x1, right? Because minus b over 2 minus b squared minus 4ac over 2 is equal to minus b plus square root of b squared minus 4ac over 2. So that's x minus x1 and x minus x2, because the same story is here. If we take minus in front of this, then we have b over 2 plus b squared minus 4ac over 2, and that's obviously this. So this is our second formula that is widely used in the mathematical world. And also this formula gives us the theta formulas. I think you might have heard of these. And basically, if we multiply, let's multiply this, all right? So we have a times x squared minus x x2 minus x x1 plus x1 x2 equals 0. All right, because we multiplied both of these brackets. And what we get is ax squared, let's actually not do that yet, minus, plus, minus x1 minus x2 in front of x, plus x1 x2 equals 0. Now we can multiply it by a plus a minus x1 minus x2 x plus x1 x2 equals 0. And we know these formulas are equal. So if these are equal, then by x squared we have a, by x we have b. So actually b is equal to a times minus x1 minus x2. We divide it by a, so b over a equals minus x1 minus x2. So minus b over a equals x1 plus x2. And that's one of the Vieta's formulas. We have x1 plus x2, the sum of two roots. And here we have c, and here we have x1, x2. So we know that, oh, I'm sorry, I forgot about a here. x1, x2, a equals c. So x1, x2 equals c over a. And that's the second Vieta formula for the quadratic function. Alright, so there are also the P and Q, and these are the coordinates of the vertex of the quadratic function, because quadratic function looks something like this or something like this. So there's this little point that is either the maximum or the minimum function of the minimum value of the function. So we should try to find it. And we know that P is somewhere between, let's just draw it here, is this always will have to be the mean of the two square roots, of the roots, because it has to be in the middle, sort of, in the middle of the function. So P is actually going to be x1 plus x2 over 2. And I think you can see that, you know, it's in the middle of both of these points. So when we have these formulas and we add these together, we get minus 2b over 2a. So it's minus b over a. Well, over 2. So that's minus b over 2a, because we add these together, so we get minus 2b over 2a, so that's minus b over a, that's what we got. And we have to divide it by 2, so that's what we get. Now for q, I think the best way is just to put it here. So a times minus b over 2a squared plus b times minus b over a, and plus c equals 0. And that's going to be our q, that's going to be our value, because that's equal to q. So we have a b squared over 4a squared plus b minus b over 2a plus c equals q. So we have b squared over 4a plus minus b squared over 2a plus c equals q. So what we get here is b squared over 4a minus 2b squared over 4a plus c equals q. And let me just jump over here. And we do that because minus b squared over 2a is basically minus 2b squared over 4a, because, you know, we can divide the 2's, so we can put these together. So what we get is minus b squared over 4a plus c equals q. We can put it here, so minus b squared plus 4ac equal over 4a equals q, and that's basically minus delta, so q is equal to minus delta over 4a. Right, so we derived the formula for p, we derived the formula for q, and so these are the coordinates of the vertex, which would be minus b over 2a and minus delta over 4a. So that's, again, the next reason why we denote it as delta is to, to make it shorter. Not only it indicates how many square roots there are, but also helps us to make the notation shorter. Thank you for watching, and if you're interested in any other of my videos, please do check them out. Thank you.